Today I'm going to go ahead and start creating our 2D character controller. And I'm not going to get anything fancy or anything like that. I basically just want something that can move across the screen, interact with things that I have set up in my scene. Then tomorrow in our next video, we can go ahead and take a look into Mecanim and how to add animations to it. So anyone that's actually gone ahead and looked at 2D character controllers online, especially on YouTube, you probably noticed that they're all the same. That's pretty much because, well, there's really no difference for creating a basic 2D character controller. Now, when you start getting into advanced things, like maybe you want wall climbing and everything else, then you start getting differences. But just to set up that basic jump and left and right, especially if you're just going to be using a rigid body, they're all pretty much the same. But let's go ahead and, well, let's use Unity 5 to make ours. All right, so here we go. I'm going to go ahead and use this guy. I'm just going to use one frame of the animation right now. That's all I need. And I'll shrink this down. We'll come into scripts, and I'm going to go ahead and create the simple version. I'm going to call it Character Controller 2D Simple. I'm going to go ahead, open that up in Mono Develop. And we'll go ahead and make this a little bit bigger for everyone. I like to get rid of everything right off the bat. And then I'm going to go ahead and jump back into Unity and think through exactly how I want this to work. I'm going to go ahead and just use the axis key, so horizontal, move them back and forth. And we can go ahead, just add force to make them jump. I can go ahead and use a capsule collider because he's pretty much capsule shaped with a rigid body, and that'll allow him to act or interact with other game objects in our game through physics. So with those components in mind that I know I'm going to have to work with, I want to go up here and make a few tags. Just allow multiple components. I don't want more than one of this on any one game object. And we'll go ahead and use our require component. And I think there's 3 that we're going to be playing with here. So I'm going to make just the base type. Go ahead, copy it twice. And we want to make sure that we have a rigid body 2D. Make sure you get that 2D version. I want a capsule collider 2D. And I want to make sure I have my sprite renderer. The reason why I want the sprite renderer is if we go ahead and take a look at my character here, I have the ability to change his direction just simply by toggling the X. And I'm going to do it that way. So let's go ahead. We'll start off by getting him to move left and right. And for that, we want to go ahead and set some sort of, I guess, maximum speed that our guy can move at. So I'm going to go ahead and make a serialized field, which of course is of type float. And we'll call it, let's just call it max speed. This is the max speed that he can travel. And I'll go ahead and start it off at 10. I'm going to want to go ahead and get a reference to that rigid body, the rigid body 2D, which I'm just going to call RB. And I'll go ahead and awake. Assign that reference. Now I know it's going to have it because I'm requiring it up here. Then in order to interact with the physics, we were going to use the fixed update. That's where we'll do all of our physics calculations. It's only called every X frames, as opposed to update, which is called every frame, but we still use update to gather our input from the user. Now I know I'm going to want to change some of these methods on how our character moves and jumps and does everything else later on. So instead of just putting it all in the fixed update, I'm going to go ahead and create separate methods for each one. That way there, when I want to come in and change the move code, even though right now I know it's just one line long, I don't have to worry about sorting through all of the fixed update code. It'll just be in its own method. I'll call this method move. And of course, we'll call move from here. Inside of move, I'm just going to go ahead and grab that rigid body that we have, which is, of course, a rigid body 2D. I'm going to go ahead and grab the velocity. We'll just go ahead and set it up to be a new vector. Vector 2. And of course, we'll pass in the new speed that we're traveling at this frame, which for now I'm just going to call X. I haven't actually assigned it yet. We'll go ahead and make a current speed for it. And we'll go ahead and also assign the rigid body dot velocity and the Y. So let's go ahead and do this current speed. So I got to come up here. It will be a float. It's going to be calculated every frame, even when we're not standing. And let's just call it current speed. I'll start it off at 0. And I just like my F's in there. And this is going to be calculated based on the player's input. So I'm going to go ahead and use this inside of regular update. Void update Get my spacing there before it drives me nuts. I'm going to say current speed is equal to input dot get axis. Now we notice we have 2 here, and if you hover over them, you see the difference. Get axis raw just gets the raw value, and since I'm going to be using the keyboard, every time I press a key, it's either going to be a value of 0 or a value of 1. If we go ahead and just get axis, remember when we looked at that input settings, we had gravity and sensitivity? It goes ahead and smooths the value out. So when you press it, it starts off at 0 and ramps up to 1 or -1, depending on what key you're pressing, based on the settings you have. And of course, when you let go of it, it ramps back down to 0. That's actually what I want. I'm going to go ahead and listen for the horizontal axes. And I'm just going to go ahead and multiply that by his max speed. I'm going to come down here and then replace X with current speed. And provided I have no typos, everything should be good. So we'll go ahead, we'll save this. I'm going to go jump back inside of Unity. Give it a second. We have no typos. Great. I'm going to go ahead and take the character controller 2D Simple, drag and drop it on. And we see that we got our capsule collider, our rigid body. And we already had a sprite renderer, so it didn't bother adding that. And let's go ahead. First thing I'm going to do is zoom in on my capsule collider. I'm going to bring it in a bit. I don't care if it cuts off some of the arms and legs. Depending on the sprite you're using, you might want to go ahead and change this a bit yourself. I'm going to go a little bit there. And for Y, let's bring it down. Oops, that's way too much. Actually, we are going to get the legs in there. And I'm not sure why I jumped back. I think I will go like that. I'm trying to just line it up right here. Previously, before we got the capsule collider, we always went ahead and did a circle and a box collider, but we don't need that anymore. All right, so I've got that set up. For rigid body 2D, I'm going to leave it as dynamic. I do want to use gravity. I might play around with that a bit. I am going to freeze the rotation on Z. Kind of want them flip-flopping back and forth. And that should be good. Let's go ahead. We'll start it up. They'll fall to the ground. And we can move them. That's pretty fast. So let's go ahead. Slow them down a bit. Maybe half of that speed. Yeah, I like that. So a 5. I'm going to go ahead and put that there. To be honest, I'm going to go ahead and hard code that in here as well. Even though the value that you have stored in the inspector does override what you have in your script, provided you're not changing it down here, the default value will override. If I go ahead and drag and drop this onto another sprite that I want to act as a character, I just want to make sure I have the same value set. Okay, the next thing I want to do is go ahead and change the direction when he's moving to the left and to the right. So we jump back in. Like I said before, all I want to do is just toggle the flip here. So when he's moving to the right, which is going to be positive on the horizontal, so we know it's a positive value, make sure it's not checked. And when he's moving to the left, which is going to be the negative value, make sure it is checked. So we'll jump back into the code, make a new method, void change direction. Now we've already actually calculated what direction he's actually going. Now the current speed is going to return a positive or a negative value. So all we have to do is just check that. So I'm going to come down to change direction, and we're just going to say, if the current speed is greater than 0, then we can go ahead and flip that value. But I don't like to just go in and flip. I like to actually go in and check to see what the value is before I flip. So we are going to need a reference to that sprite renderer, which is fine. We'll just come down here. Sprite renderer, which I will call SR. And just like down here, SR is equal to get component. The component we want is our sprite renderer. Down at the bottom. And we'll come down. And we're actually going to check here as well. So we're going to say and SR dot, nope, SR bounds dot flip X. Notice we can get and set the value. But what we're saying here is if the current value is greater than 0, meaning we're moving to the right, and SR.flip, which means that it is checked, then we want to go ahead and uncheck it. So SR.flipX equals false. So we'll go ahead and uncheck it. Now, there's only other one condition here we can check for. That's the if, else if. Now we're going to say if the current speed, I can type. Now if it is less than 0 and sr.flipx, but we're going to go ahead and put a not symbol in front of it. So we're going to say if it's not checked, then go ahead and check it. So it's going to equal to true. And I just want to put a space in here. There we go. And of course, we want to call this. This has nothing to do with physics. So I'm going to put it in the update. And of course, after the current speed is checked, that was change direction. I'm going to go ahead and save that off. We'll go jump back into our game. No errors, so we'll go ahead and hit play. And if we take a look, now when we go left and right, his eyes change. Kind of like that. All right, let's go ahead. We'll stop it. And let's go ahead and do the jump next. So we'll jump back into our script. And I guess I'll make a method for it, jumping. So void jump. And all we're going to do is go ahead and apply force. So RB dot add force. And we're going to apply the force in the upward direction. So I'm going to use vector2 dot up multiplied by some value. So just like with speed, we'll have a jump power. I'll go ahead, serialize my field, create another float. And I'm not sure what value to start off with here. So I'll do 500. It's probably way too much. But that's fine, we can edit. Now for calculating when to jump, a lot of times you'll just see people, since we're going to be using add force, throw it either into update or fixed update. But I really want to drive home the whole keeping the physics inside of the fixed update and the input inside of the update. So when the player goes ahead and hits whatever key we want for them to use for jumping, let's say space, I want to capture that in the update. The problem is I have to be able to store it somewhere so that when the fixed update is called, I know that that key's been pressed. So I'm going to go down here and create a Boolean value. And I'm just going to call it jump. And by default, I'm going to go ahead and set it to false. Then inside of our update, this is where I'm actually going to grab the value. So we're going to say if input dot, and we'll just use a key for this one. And I'm going to use get key down. And the key I want to use is we're just going to go by the key code. And I'm just going to use spacebar for this. So when the user presses the spacebar, let's go ahead and set jump to equal true. And we're going to come down and do our jump method here. And we forgot to finish this line. This was jump power. So when it's time to jump, we go ahead, take the rigid body, we're going to add a force in the upward direction multiplied by the power. But now we can go ahead and add this if statement. And we're going to say if jump, is it time to jump? If so, jump. And the method call to this, since this is going to be handled with physics, I want to call from fixed update. So we call jump. Let's go ahead, save that off. We'll jump back into Unity and let it recompile. No errors. We'll go ahead, hit play, watch them down here. When we hit the space bar, whoa, 500 was too much. Let's try 100. Well, 100 is still too much too. 10. We'll just keep cranking her down until we find the value that we want. 10's not enough. And he's just floating away. And that's because it keeps adding 10 every frame. What we need to do here is when we go ahead and add that force, we want to make sure that we go ahead and set jump to equal false again. So until the player hits the spacebar again, we can't jump. So let's go ahead. We'll jump back into Unity again. Go ahead, hit play. And 10's not enough. Let's go 50. 50, not quite enough. Wow, how things have changed. Maybe 500 was a good number. Nope. There we go. There we go. So now he can run jump, change direction. Yeah. And because we have physics hooked up, he can interact with our objects. I'm not sure. I think I want him to fall faster. I'm just going to go ahead and change his gravity. Now, of course, for those that have been in the Discord for BurgZerg Arcade, know exactly how this game works. Anyway, so I'm going to go ahead and change his gravity. The 500 was good. Let's try and increase his gravity by 3. Now when he goes ahead and jumps, it comes down a lot quicker. Not sure I like how fast he goes to the bottom. What if I auto mass him? Yeah, that's too buoyant. We'll go ahead. We'll play around with that later. Right now we have him jumping, turning, interacting. Of course, the problem is you can just constantly keep jumping. So I'm going to go ahead and set it up that he can only jump one time until he actually hits the ground again. And for that, we'll come up to the top. And there's a couple ways to do this. We can go ahead and, well, let's actually look at it in Unity. We can go ahead and take all of the ground and set it to the ground layer. And I've actually already done that. If we go ahead and take a look, if I click on it in the scene view, I've already gone ahead and set it to the ground layer. And I've done that for all my ground. And then for my water, I went ahead and set to the water layer. And I believe my crate's just default, right? Yeah. Now the way we could work this is go ahead and when he touches the ground, set it to that you're is grounded. And then when you hit jump, go ahead and set it to be not grounded. And of course, while he flies around until he actually hits the ground again, he can't jump. Well, at least he can't jump again. This is the way I normally do it, but generally for 2D games, you see a lot of people putting a little transform underneath, and it gives a more visual representation of it. So let's just go ahead. We'll do it that way. I'm going to go ahead, create an empty under him. Let's actually go ahead and pick him first. And I'll call it ground trigger. And you generally move it down a bit. You see the blue dot? I'm just going to put it right between his legs. Too easy. I'm going to go ahead and save the scene off. Make sure nothing crashes. Go ahead, jump back into Unity. Or sorry, into Mono Develop. And let's set that bool up for being grounded. So bool is grounded. And I'll start it off as false. And we're also going to need that transform. So I'm going to go ahead and put that under here too. And I'm going to assign it in the inspector. So we'll go ahead and grab its transform. And I called it ground trigger. So I'll save that off. Quickly jump into Unity. Assign it before I forget about it. And I'm going to shrink some of this stuff up for now. We'll go ahead. We assign that. Great. Save again. Jump back into Mono Develop. And I'm going to come down to the fixed update. And this is where we actually do the check to see if we are grounded. And this one I'm actually just going to throw in the fixed update. For homework, go ahead and move this out to its own method. And I'm just going to say is grounded is equal to, and we're going to be playing around with the physics 2D dot overlap circle. There's a whole bunch of overlaps here. We're just going to go ahead and go with the circle. And we'll go ahead, get the ground trigger position. And then we also want to cast it out into a radius, which I have not set up yet. So let's do that next. And I'll put that right above the transform. Serialized field, which is a float. And I'll just call it ground trigger radius. And I'll assign that to something really small, 0.1. Looks good. Come back down to fixed update. Finish this off. So we go ground trigger radius. And then we also want to be able to check the layers that we want to include as ground or our surface that's going to trigger the ability to jump again. And we can do that through layer masks. So again, we'll make another serialized field. But this time it's going to be of type layer mask. And I'm just going to call it ground layer. And we'll come back down, put a comma. Ground layer. Now we can go ahead, save this off, jump back into Unity. And most people go ahead and put some sort of gizmo on it. But the gizmo actually really doesn't tell you how close you are to the ground because the gizmo is not the size that you're setting for that radius. So what I like to do is actually come back in. And there's a function for drawing gizmos. And it's void on draw gizmo selected. So when we have this guy selected, we'll actually see this gizmo drawn underneath him. I'm going to go ahead and set up the gizmo.color. And let's stick with that blue. So color.blue. Then let's go ahead and set it to the size as well. So I'm going to use gizmo or gizmos. And there's a few we can draw here. Since we're actually using an overlap sphere, let's actually draw a sphere. Or sorry, a circle, but it's actually called a sphere. And we got to go and tell it what position. So we're going to say ground trigger position. So the position that we have set up for the ground trigger. And we also need a radius. The ground trigger radius. We'll go ahead, save that off, jump back into Unity. And now when we select the guy, we see the little blue dot. And you want to make sure, we open up the capsule collider, it's below the capsule collider. So I can just go ahead and move it down a bit more. The second part, I should say. Of course, you could just make it bigger as well. And if we jump out of 2D, you see that it actually is a sphere. But that doesn't matter. It actually doesn't interact with anything inside of the game for us. We just want to make sure it's below the collider. And again, like I said, you could just make it bigger. If we came up here, let's make it 0.5. We jump back into Unity. Take a look. Let it recompile. Oh, wait. I changed it up there, but we have to change it in here. There we go. And he's got some giant blue ball. Let's go and put it back down to 0.15. Sure, that looks good. Like I said, it just has to be below that collider. So I'm going to jump back in and put a 1 in front of there. So we've got the gizmo drawn. We've got it set up so that we can tell if we are grounded or not. So we got to actually do something with this variable. And what we are going to do is come up here. And we want to check to see if we're grounded when we're either pressing the space bar or when it's time to jump down here. One or the other, we really don't need to check both. So I'm just going to check at the time of input. So we'll come in and say, if they're pressing the key we want to assign to jump and they are on the ground, then we're going to go ahead and set the jump value to true. And then when it comes down to jump, it's going to say, hey, well, it's actually in fixed update. The next fixed update is called. We'll go ahead and add some force. Now, as far as calling it from fixed update, the jump itself is not going to be as instantaneous. It might cause a little bit of lag for the jump. And if that is the case, I'll just go ahead and change it around so it's called from update when they press it. But for now, at least for this iteration, I want to make sure that all of my physics calls are done inside of fixed update itself. But I'm pretty sure I'm going to have to move at least this one. Let's go ahead, we'll save that off. We'll jump back inside of Unity. I'm going to go ahead, hit play. And, oh, we couldn't jump. That's because I did not set my ground layer. So I'm going to go in and I'm just going to select ground for now. And if we go ahead, hit play, and we start jumping, you can jump. But if we notice when we hit the water, you can't jump in the water. So what we can do is go ahead and select is grounded, or sorry, the grounded layer, and select the water layer as well. So now he can jump in either one of them. And maybe later on, we'll go ahead and say that when he's in the water layer, he can only jump maybe half the height or something like that. There we go. Come up, try to this to this side. No, oh, Get up under it. Pop it. Pop it. Come on. Oh, there we go. There we go. We got it live on camera. I told you I could do it. Anyway, that's pretty much all I wanted to get done in this video. You can go ahead and start seasoning these values to taste the way you want your character to work. And in the next video, let's go ahead and actually start adding some animation to them. Anyway, I'll see you over in the next video. Bye-bye. Let me out of the water. I'm drowning. I can't get out. There we go. So if you liked the video, go ahead and hit that subscribe button down below. It really does help me out here on YouTube. And go ahead and follow me on Twitter. I can be a pretty chatty guy over there when I'm not walking through a forest or being stalked by eagles and falcons, lions, tigers, and bears.